Picking up where we left off, number 10 says, based on this graph, explain how you know whether the equation that models the situation is linear or not. Well, I can tell it's linear because it looks like a line. It was straight. It had a constant rate of change. I went up $2 for every hour that I spent. I went up $2 for that hour. I went up $2 for that hour. So we would say that the dots connected to make a straight line. Why did the graph, explain why the graph is only in the first quadrant? Well, what's over here in quadrant number 2? We would have negative hours and positive costs because we have negative X values. What's in quadrant 3? Negative X values and negative Y values. So negative hours and negative cost. Negative hours and negative costs do not apply in this problem. Okay, what is the y-intercept of the graph? Well, there's where the line crosses the y-axis. So the y-intercept is 5. Describe what the y-intercept represents. The initial cost of renting the tube, or if you put the flat fee, that's totally okay and acceptable too. What is the slope of the graph? The slope of the graph is, what did we say? We said rise to. Remember, slope is rise over run. And here's the best way to explain what the slope is. We did rise 2 and we run 1. We went up 2 over 1 hour. So we went up $2 and we went over 1 hour. So we would say it represented $2 for every hour. Now, could you say it a different way? Of course, $2 per hour. You went up $2 every time you spent an hour there. Lots of different ways to do it. Okay, I've added this question. It's not in your Springboard book, but it is on your homework. So I wanted to go ahead and add this question. If a customer has $15, will they be able to stay for 5 hours? Explain algebraically and graphically. So algebraically, well, we have the equation that we wrote. Remember, we have y equals 5 plus 2x, okay? That was the equation that we wrote, and here is a number of hours. So we could take that number right there and plug it in and say y is equal to 5 plus 2 times 5, and 2 times 5 is 15, 2 times 5 is 10, 10 plus 5 is 15, so we get a total cost of $15. So if a customer has $15, will they be able to stay 5 hours? And the answer would be yes. So that would be an algebraic explanation. Yes, 5 hours has a cost of $15. Okay, so that would be, this is an algebraic explanation. A graphic explanation would be to come over here and say, well, yes, because this dot right here, 5:15, is on the line that was graphed by the equation that we wrote. So 515 is a solution to that line. Now let's talk about what if the person had $20? Would they be able, or since we can see 16, would they be able to stay for 5 hours? If a person had $16, so here's the point right here, 216. I'm sorry, it's 516. I don't know where the 2 came from. There's the point 516. If I stay 5 hours and I have $16, if I have $16, can I stay for 5 hours? The answer is yes. It's not on the line, but it's above the line. So, we actually have more money than we need. So on the line, you have exactly enough money. Above the line, you have more money than you need. Well, what's going to happen if for this person right here? Okay, they want to stay for 5 hours and they have $13. Do they get to stay for 5 hours? And the answer would be no, because $13 is not enough. They needed exactly $15. So any point below the line means that they have not enough money for that many number of hours. On the line is exactly, above the line would be I have more money than I need. So you're going to be asked a couple of questions about that in your homework. Okay, let's go over here. I have a couple of extra questions that are about vocabulary and writing equations and paying attention to positives and negatives. So my son sold cups of lemonade at a pull for $1 a cup. This is a true story. My son is a born salesman. Since the day he could walk, he's tried to sell stuff. Cookies, artwork, and now as an adult, that's what he wants to do. He wants to sell high-end cars or houses. So he wants to sell a Porsche or he wants to sell a mansion. So we'll see. Maybe he'll get there. I told him before you can sell a Porsche, you got to sell a Kia. But anyway, we'll see. He sold lemonade for $1 a cup, but being the good mother that I am, I had to teach him, Mama's not going to go buy the ingredients and then let you keep all the money. So he took his allowance and bought the ingredients, and he spent $11 on sugar and ice and cups and lemons and all of that. Now, I did help him make it, and I did not charge him for my assistance. So he needs an equation that'll give his profit, and we're going to use the variable y, and we're measuring it in dollars as a function of. So that means that we're going to say y equals, and then the x is in the calculation part of the equation. We could actually do this like this, write this as a function of x, put the f of x in the place of y. You remember function notation from Algebra 1 and from the warm-up if you did it, the getting ready. Either one of these would be acceptable, but since they specifically told me why, I'm going to go ahead and use it. So write an equation that gives the profit y in dollars as a function of the number of cups x that's sold. So let's see, how did this work? He spent $11. So that's money that he's already spent. What can we do to represent amount of money that he's already spent before he's even sold any cups? That's kind of like saying I'm $11 in the hole. He started off with $11. Now I put the negative 11 out here because I was going to put, it doesn't have to be. You could put the negative 11 in the front. So I'll do it here. Either way. And then we've got to take this negative $11, and take it away from how he makes money. Well, how is he making money? He's making money $1 for every cup. So this is going to calculate his profit. So in order to get a positive number, he's going to have to sell, several cups of lemonade before he has a positive profit. Now, the fact that we start off with the y-intercept that's negative, I'm going to go ahead and finish this one. Either one of these will be the same equation. The fact that this has a negative y-intercept means that we can't just do this one in quadrant 1. We're going to have to go down and include quadrant 2 as well, because I'm such a hardcore mama, I made that little baby start off in the hole. He had to sell 11 cups of lemonade before he started making any profit. But that's the real world. So you do need the first and the fourth quadrants in this one. Negative money means something in this equation. And it means that he didn't sell enough cups. He had to spend his own money before he could go into business, and that's real world. Okay, so let's do another one. A helium-filled balloon is first noticed floating 25 feet above the ground. It's losing altitude at a rate of 2 feet per minute. Write an equation that gives the altitude h of the balloon as a function of, so h is going to be what we're calculating, and we're going to calculate h by using this t somehow, okay? So noticed it was first noticed 25 feet above the ground. So here's the ground, and we see the balloon, and it's up here. And then it says it's losing altitude. What does that mean? That means that the next time we see it, it's going to be a little bit lower. And we know that it's losing it at a constant rate because it says right here at a rate of 2 feet per hour. Okay, so it's at 25 feet, then it's an hour later, it's at 23 feet, then it's at 21 feet, and it just keeps going down like that. So that means that the slope, and you notice right here, because remember slope face, we've got positive, we've got negative, undefined, 0. Okay, our line is lining up like this, so that means it has a negative slope. So if we write our slope first, negative 2 feet, and it said use t for time, negative 2 feet, and it started off up here at 25. Okay, so this is an example of having a negative slope because it's doing something, it's going down, it's decreasing, its height or its altitude is decreasing each hour. So that's going to have a negative slope. You could, of course, written it the other way. You could have said it started off at 25 and it's decreasing 2 foot per hour. Either one of these is saying the same thing. The only difference is the order in which we put the y-intercept versus the slope. Okay, this is still the slope because it's with the t, and it doesn't matter whether it's here or here. It's still the slope because it's with the variable. This is the y-intercept because it's the one without the variable. It's the place where we started. It's the y-intercept, or the b in our y equals mx plus b equation. Okay, this one is a little, actually I'm going to go ahead and stop the video because I'm afraid if I start talking about this one, I'll run over on time. So I'll stop the video right here and do this last example in a minute.